Hey everyone, today we're going to keep working with areas between functions, but we're going to learn a new method that's going to help us address some trickier problems like this one that came up yesterday. So if you remember, we were asked to find the area of the region in the first quadrant that's bounded above by y equals square root of x. I think this is extra. Above by y equals square root of x and the line y equals x minus 2. So let's go ahead and see what this looked like here. Sketch a quick graph here to refresh our memories. So y equals the square root of x. I'm going to make that in blue here. So if I plug in 1, we get 1. Then I'm going to do 4, 2. So I've got this here. And then we have y equals x minus 2. So my y-intercept is negative 2, up 1 over 1. There we go. And then, all right. So we're trying to find, right, only the area in the first quadrant, so bounded by these curves. But what we noticed yesterday was over this interval between 0 and 4, that bottom function changed. So if we look at this purple interval, my top was my blue curve, my bottom was the x-axis, but then as I move along to the right here, now the top is the blue curve and the bottom is the orange. So we had the need yesterday to actually write two separate integrals. So we needed the integral, first of all, kind of this purple region was from 0 to 2. Our top was square root of x, and the bottom was really 0, y equals 0. So we had square root of x dx. And then we were adding the integral. Now we switched, our x values were from 2 to 4. Our top curve was still square root of x, but now our bottom was this x minus 2. So because kind of that bottom function changed, we needed two integrals. And especially when we're doing this with no calculator, that gets to be pretty cumbersome. So again, this problem was challenging because I'm going to say the bottom function changed within the interval. So we needed two integrals. So again, it will work, but it just makes things a little more cumbersome to deal with. So today we're going to learn a new way of solving area problems that's going to make some problems easier. And this method involves integrating with respect to y. So before we jump in, here's what I want to note. So far, all of our integrals have been with respect to x, right? So we had dx's. Our limits of integration have been x values. And our integrand here has been in terms of x, which means we isolated y to start. We always had something that said y equals. So everything's been in terms of x. And now we're going to change that and we're going to be with respect to y. So all of our variables be in terms of y. So this is how it's going to look. Instead of thinking top minus bottom now, we're going to be integrating right minus left. And our integral is going to be dy. Now, when we set this up, our bounds here, our a value is going to be our lowest y value. It's no longer an x value. B is going to be the highest y value. We're going to have a dy, and now our integrand here is going to be in terms of y. So let's go ahead and take the same problem. We're going to leave this example blank, but we're going to take this same problem now and look at what it would look like to integrate with respect to y. So the first thing I'm going to do here is just draw my curves again. Okay, so I'm still going to make this one is going to be square root of x. And then we'll have y equals x minus 2. All right, so we're still looking at that same region, but now here's what I want you to realize. If I'm looking at this region in the first quadrant here, if I'm integrating with respect to y, so I'm going to shade it in this way just to show them integrating with respect to y. And what I want you to realize now, if I look right minus left, the furthest most right boundary of that curve is always going to be my orange line. And my left boundary here is always going to be the blue curve. So now I don't have to worry about having two separate integrals if I integrate with respect to y. Again, my right boundary is going to be this orange line here, y equals x minus 2. My left boundary is the square root of x. So let's take a look here at how we would set this up. Now the first thing to note here when we're integrating with respect to y, we said our bounds of integration are going to be y values. So if I look here at this shaded region, my lowest y value here is going to be, if I look at this point, the y coordinate there is 0, right? I know this point is 0, 0. Now here, my highest value, I know that ordered pair is 4, 2. Since I want y values here, that upper bound of integration is going to be 2. Again, I'm grabbing the y value. Now, we said when we integrate our functions here, they're going to need to be in terms of y, which means I need to isolate x. So we said our right is our orange curve here, y equals x minus 2. Since I need this to be in terms of y, I'm going to isolate x by adding 2 to each side. So I get x equals y plus 2. And that's what I'm going to put here for my right curve. Okay, so I'm going to make a note, that's my right. And now I need to take my left, which was y equals square root of x. To isolate x, I'm going to square both sides. So x equals y squared. So I'm going to subtract that since that's my left. I'm going to close this up, and then I finish with a dy. All right, so that's our setup. Again, our right minus left. That's going to help us because now we only need to set up one integral. And that's when integrating with respect to y makes some problems easier. So now, for the interest of time, we're just going to use our calculator to do this integral. So let's see, Math 9 from 0 to 2. Now, when I put it into my calculator, I'm just going to put x. That part doesn't matter. And I get, it's approximately 3.333. But again, much simpler than having the two integrals that we had yesterday. All right, so let's look at another problem, a new problem here. And we're actually going to look at it both ways. So we're going to look at it with respect to x and with respect to y. So here it's asking us to find the area of the region enclosed by the graph of y equals x cubed and x equals y squared minus 2. So we'll start with respect to x. And remember, with respect to x means top minus bottom. So let's do a sketch here. So y equals x cubed. All right, so I'm going to start with y equals x cubed. I know what that looks like. I've got a point at 0, 0. I'm going to have 1, 1, and then 2, 8. And then negative 1, negative 1, and negative 2, negative 8. So I know it looks something like, oh boy, not the smoothest graph, but I get the idea. All right, so there's my y equals x cubed. Now this one, it's a little harder to tell what's going on, so maybe we'll use a table here. So I'm going to do an xy table. And let's see, maybe we'll do negative 2, negative 1, 0, 1, 2. So if y is negative 2, and remember, now I'm starting with y here. So negative 2 quantity squared is 4 minus 2. That gives me x is positive 2. If I plug in negative 1, 1 minus 2 gives me an x of negative 1. 0 is going to give me an x of negative 2. 1 again gives me negative 1, and then 2 gives me a positive 2. So let's plot some points here. And again, we're going to go back to our calculator in a second, but I want us to realize that we have another way of dealing with these if we don't have a calculator. So negative 1, negative 1, negative 2 is 0, negative 1, 1, and 2 is positive 2. So it looks something like that. So now, if I'm integrating with respect to x, that means top minus bottom, something interesting again is happening, because if I start looking at top minus bottom, up to this point, my top is the top half of the orange curve, and my bottom is the lower half of the orange curve. Once I get past that point there, it looks like at negative 1, then it switches. My top is still the top half of that orange curve, but my bottom now is the blue curve. So again, this is what's going to cause me, if I'm going with respect to x, to need two integrals. So for my first integral, we're going to take the integral from, let's see, we'd have negative 2. This I can tell from my sketch is negative 1. Now, with respect to x, I need both functions to be in terms of x, which means I have to rewrite this function. So let's take a look. I've got x equals y squared minus 2. I need to isolate y, so I get y squared equals x plus 2, and then y is plus or minus the square root of x plus 2. So now this one's interesting. Now my top is going to be square root of x plus 2 because that's the positive, and my bottom is going to be the opposite square root of x plus 2. Okay, so that's for the green region. So I'm just going to underline this. That's my integral for my green region. Then I need to add, and I'm going to draw a line here so I don't go too far over, the integral from, let's see, now I'm from negative 1, and I need to find the x value of this intersection point. So let's use our calculator to help us out with that. So let's see, I have the square root of x plus 2. I have opposite square root of x plus 2. And I've got x cubed. I'm going to graph those, and I'll probably have to change my bounds. Maybe not. Nope, we're good. So what I'm looking for is the x coordinate of that point of intersection. So I'm going to go over here. Get back to the right curve. And I get 1.215. Again, this is with respect to x, so I want the x value. Now for this, our top is still positive square root of x plus 2. But the bottom now is the blue curve, which is x cubed dx. So now that I've got all of this, again, this was my purple region here, I'm going to add those two together. I'm going to use my calculator to do that. And we'll see what we get. So -2 to -1, I've got square root of x plus 2 minus the opposite square root of x plus 2 dx plus the integral from -1 to 1.215, got square root of x plus 2 minus x cubed dx, and I get 4.215. All right, so that's with respect to x. Again, we needed the two integrals because those bounds, those lower bounds changed, but we're able to get to an answer. So now let's take a look and see how this would look with respect to y. So I'm going to do a quick sketch again of those same two functions. That one was a little better. All right, so there is my blue curve, and then this guy, using my same points. Okay, so there was our region. Again, we can see the area trapped in between here. But now we're going to go with respect to y, which means I'm going to shade it in. I just like to shade it in this way to keep myself straight. So I'm going with respect to y. And when I do that, I can see my right boundary here is always the blue curve. My left boundary is always the orange curve. So I know I'm only going to need one integral. So let's go ahead and see what that would look like. So now we're going to be taking our integral here, and remember, we're looking at the y values here. So I know this point was -1, -1, and I'm going to go to my calculator to remind myself what this point was. Got the same graph. I'm going to find that intersection point again. So this was 1 point, and then 1.793. So remember, now we're with respect to y, so my boundaries of, or my limits of integration are the y values. So now I'm going from -1 to 1.793. And now I'm doing right minus left. So I'm going to make a note here. With respect to y is always right minus left. So my right, we said, was the blue curve. Now if I'm going with respect to y, right now this function is in terms of x, so I need to isolate x. And I'm going to do that by taking the cube root. So x equals the cube root of y. So my right boundary is the cube root of y. My left boundary is orange, and x is already isolated, so I've got minus y squared minus 2. And we'll finish that off with our dy. So again, by integrating with respect to y, we can just have one integral here. So now we're going to calculate this. Let's see, so 1/3 minus x squared minus 2. My calculator's stuck. There we go. And we're still going to get 4.215. All right, so the idea here is, again, integrating with respect to y is going to simplify some of these problems. You can always do it. You're going to have a little bit of choice here. Some people decide they always like working with respect to x, but again, the idea is integrating with respect to y, so switching our focus from top minus bottom to right minus left is just going to simplify our process a bit. So we'll end there, and we'll go over number 3 when we're back in class. All right, thanks.